very high pressure associated with it, and that friction prevents the machine from pushing forward. So methods to reduce or increase that clearance, give the geology more room to move is important, and involving a couple of different items here. Primary among these is overboring. In hard rock, you want a real stiff load path in order for disc cutters to be able to be functional or work well. So that's primarily done with shimming out the gauge cutters. You can see on the right-hand side kind of how that's done. So multiple tools are stepped around in order to form ultimately the tunnel. And by shimming them out progressively, you can increase this overbore. As the rock becomes a little bit softer, we start to be able to use hydraulic. The upper right-hand side is an example of a hydraulic overcutter that's been used. This is for slightly harder rock where that cutter is pinned into position, creating a stiffer load path. But as the geology becomes softer, including EPB machines, up to 20, 25 MPa, somewhere in that range, it's strong experience in installing tools at the end of hydraulic cylinders. When you get overcut beyond a certain limit, you're going to start to ultimately cut underneath the machine, increasing the tunnel diameter, and this is going to cause diving issues for your machine just because it's designed to ride on the invert. So how that's addressed is by shifting the full cutter head, main drive cutter head, up vertically to optimize the amount of overcut at the invert. What we're looking at here are two different machine types. The one on the left is an open type machine, and you can see on the lower portion hydraulic cylinders attached to a vertical front support. These are used to lift up the cutter head support, and shims are installed underneath. This is what we're looking at here is about a 6.5 meter machine, open machine. The image on the right is of about a 10 meter shielded machine. It's a little bit more difficult to install this on a shielded machine just because of how the drive system is connected to the shield, but it is something that is still possible. What we can see here is, again, hydraulic cylinders located on the lower part of the shield, and then the attachment points on the sides, we can shift it up one bolt hole pattern. Along the lines of trying to keep the geology away from the shields, this is really one of the areas that open TBMs have a big advantage, and that's because, first of all, the forward shield, the blue area you see on the left-hand side there is articulated, so it's able to move in. Most shielded machines are fixed to shield, so they're at fixed diameters and aren't able to articulate in. You'll also note that the majority of the equipment on the machine is located towards the center line, so this gives a lot of room and flexibility to give room for the ground to move in once that forward shield is passed. That being said, that's shielded machines. We're still able to accomplish the same idea, and that's by using steps on each successive ring, bringing them down in diameter to give more room as the ground comes in. Usually, especially squeezing ground is a time-related phenomenon. So as the machine advances, you have more and more clearance to accommodate that ground being brought in. There's a cost to be paid with this, obviously. You have increased grout. You have to deal with fines, that sort of thing. But ultimately, if you have squeezing ground conditions, it's something that's required in order to get through the ground. If the ground does come in contact, it's friction that really kills you. And so a good way of dealing with this is by putting friction-reducing agents along the outside of the shield. In most cases, you're able to do this with bentonite lubrication through periphery ports in the shield. If you do have a squeezing ground coming in contact with the shield, many times that contact pressure exceeds what the pumps are able to put out. So some cases, high-pressure fluids and agents need to be injected along the shield. So reducing the friction makes your thrust more effective. The other half of that is increasing the thrust available to you. This can be done in multiple ways. On the initial machine design, high-pressure cylinders or high thrust can be installed on the machine from the very beginning. In some cases, that's difficult to do or expensive to do. If you run into these conditions, a unique solution that was come up with in the past is the addition of hydraulic cylinders